Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the top stories in science and politics in the past week. Our lead story today concerns the Trump administration declaring Star Wars 2.0. That's right. It was back in 1983, 36 years ago, that President Ronald Reagan debuted a Star Wars program to, quote, make nuclear weapons obsolete. Well, nothing much came out of that. However, now the Trump administration wants to use today's technology to create a new Star Wars shield around the United States. And the question is that a good idea? Is that going to give us peace and stability, or will it be costly and destabilizing? So we'll say a few things about that as well. Also, the Bulletin of the Atomic Scientist has that doomsday clock, and they just announced how close we are to midnight. Midnight means doomsday. And ever since 1947, the Bulletin of Atomic Scientists has alerted us to potential dangers of confrontations and disasters. And, well, this year it's still set at 2 minutes to midnight. So we'll say a few things about the relations between the United States and Russia. Between them, they control 90% of the world's nuclear stockpiles. And we'll say a few things about North Korea and also global warming. Global warming, says the Bulletin of Atomic Scientists, is one of the reasons why we are still 2 minutes to midnight. And then speaking about the weather, then we're going to go to the South Pole. Scientists were elated to find that they could drill a hole right into the ice sheet of Antarctica, drill 7,000 feet straight down, setting a world's record. And the question is, what does it mean? Will we be able to extract ice cores going back millions of years into the history, the prehistory of the Earth? In other words, will we be able to take a thermometer and exactly calculate what the temperatures were on the planet Earth millions of years ago? And also last week on Exploration, we mentioned the fact that at CERN, outside Geneva, Switzerland, they're preparing proposals for a new atom smasher, even bigger than the Large Hadron Collider. Well, not to be outdone, now the Chinese and the Japanese have announced their plans for a super atom smasher, which will then propel us into the next generation of physics. And then the next question is, well, where's the United States? We have CERN in Geneva. We have the Japanese in Tokyo. We have the Chinese in Beijing. All of them proposing a successor to the successful Large Hadron Collider. But where's the United States in all of this? We'll say a few things about that on Exploration. Well, let's just jump right into some of the top stories of the past week. The big story today is that the Trump administration finally unveiled its long-awaited missile defense plan. Of course, President Donald Trump talked about a Space Force last year. In addition to the Air Force and Army and Coast Guard, we're going to have a Space Force devoted to defending the United States' interests in outer space. But now we're talking about the whole defense posture in general. And that is Star Wars 2.0. In other words, back in 1983, President Ronald Reagan was supposed to deliver a very ordinary speech about our defense establishment. Instead, he shocked his advisors by pretty much throwing away the speech and extemporaneously ad-libbing a Star Wars program that will, quote, render nuclear weapons obsolete. And immediately the press dubbed it Star Wars because we imagine that there'll be laser beams in outer space, ray guns, all sorts of fantastic Buck Rogers weaponry to shoot down missiles in case of a nuclear war. Now, at first glance, it seemed like, well, a reasonable idea. It's a defensive shield. It's not offensive. You're not going to be able to attack the enemy with a shield. But then other people pointed out that if you do have a shield, it can cover up a first strike. In other words, what is destabilizing about a Star Wars program is that if you have a Star Wars shield that's 100% effective, then you are invulnerable to an attack by the enemy, and you can hit the enemy in a first strike anytime you feel like. So in other words, a Star Wars shield is not just defensive, but it's offensive as well. You strike first with the first strike with nuclear weapons, and then you raise your shield to ward off a weakened second strike. That's a scenario that the Russians always talked about because, of course, they were at the receiving end of a Star Wars shield, but it was never picked up by the press here. So most people still think that a Star Wars shield is strictly defensive. So in actuality, a Star Wars shield is part 2 of a potential first strike. Well, what happened to the original scheme of President Ronald Reagan? Well, it turns out there was a problem, and that is the laws of physics. First of all, when a missile is fired from, let's say, the Soviet Union to the United States, we're talking about a trajectory that'll take about 30 minutes to 90 minutes to strike this country. That means that the warhead comes in at about 10,000 miles per hour, and you only have just a few minutes to lock onto the target and then shoot it down. And you can realize the enormous problems involved there. So we're not talking about a simple Scud missile like during the Gulf War. No. We're talking about high-tech ICBMs traveling at 10,000 miles per hour on reentry, giving you only a few minutes to strike a bullet with another bullet. So what happened to all the billions of dollars spent on President Ronald Reagan's Star Wars program? First of all, in the United States, we have Vandenberg Air Force Base, where we have the missile interceptors. Then we have the missiles themselves fired from the Pacific, like near Kwajalein Island. And then the United States proudly boasted that, yes, sometimes our missiles would strike this dummy missile fired from Kwajalein. Well, they didn't also tell you that 50% of the time we missed. So would you trust World War III to a missile system that only works 50% of the time when you have advance warning that the dummy missile is going to be fired? The Soviet Union is not going to announce ahead of time when World War III is going to take place. Well, that was the problem with President Ronald Reagan's idea of a Star Wars program. On paper, it seems so simple. Shoot a bullet with another bullet. In practice, it turns out that the United States got no more than a 50% batting average in a situation where we knew exactly when the dummy missile was going to be fired. Well, it turns out that Ronald Reagan thought that he had an ace in the hole, and that was the X-ray laser. You see, it turns out that the power of a laser beam is essentially unlimited, depending upon what you use to fire up the laser. The largest concentration of power you can pack into a small package is a hydrogen bomb. So why don't you simply detonate a hydrogen bomb in space, and then the X-rays emitted from the hydrogen bomb would be focused to create an X-ray laser that can then shoot down an enemy missile from the Soviet Union. Well, that was the idea. However, it never worked. It turns out that test firings of an X-ray laser underground have always been inconclusive. So to this day, we don't really know whether an X-ray laser can shoot down an enemy missile coming at you from outer space. Well, that's the way it's been for 36 years. Touch and go. It turns out that the fundamental problem with Star Wars was the laws of physics. Well, now we have all this high-tech computer technology, and the Trump administration wants to come out with Star Wars 2.0. So what's the difference? The difference between the original Ronald Reagan plan and the new Donald Trump plan. Well, the basic difference, once you read the report from the Pentagon, is that the United States is no longer looking at shooting down a missile during the reentry phase. when you only just really have a few minutes to shoot down a missile coming at you at 10,000 miles per hour. No. They want to shoot down enemy missiles in the boost phase, when the missile is just lifting off the launch pad. The velocity is very low. It has a very prominent heat signature, very easy to lock onto in principle, and then you can shoot it down with sensors and laser battle stations in outer space. So before, the Reagan administration visualized ground-based lasers with unlimited power hooked up to the grid that has enough energy to shoot a laser beam that might be able to lock on to a Soviet missile. The Trump plan is different. The Trump plan wants to use satellites orbiting in outer space, not ground-based lasers, to shoot down an enemy missile during the boost phase. Well, is that possible? Well, it turns out that in order to have satellites positioned just right during the boost phase, you have to have about 2,000 of them orbiting the Earth at any given time. And that is a nightmare. You see, when the boost phase rocket takes off, let's say from North Korea or the Soviet Union, you have to have a satellite going at 18,000 miles per hour orbiting just at the right position to shoot down the missiles during its boost phase. That means you have to have thousands of them orbiting the Earth simultaneously, so that at any given time, a surprise attack could be then caught on radar, and then you can shoot down the enemy missile. That's one problem. The nightmare of having 2,000 of these satellites orbiting the Earth at any given time. The second problem is energy. You see, under the Ronald Reagan plan, you could simply plug into the power grid, and you have unlimited power to energize your ground-based laser to shoot a warhead in outer space. Power was not the problem. But you see, if you have a satellite, the satellite is not connected by a plug to the planet Earth. No, it has to have its own portable power pack. And that's another headache. At the present time, we simply don't have a portable power pack that is powerful enough to energize a laser beam that could shoot down a missile in its boost phase. Now, of course, the Chinese and the Russians aren't taking this lying down. They have their own plans, too. And their own plans include the hypersonic drone. So, let me explain. When an enemy missile comes down from outer space and it's maneuverable, it means that any Star Wars system on the Earth has to not just lock onto the missile, it has to lock onto where the missile might be in the future because it's maneuverable. And last year in March, Vladimir Putin announced that yes, the Russians have perfected a hypersonic missile. A missile that's maneuverable, a missile that can evade a Star Wars system. And the danger there is that if you really do have a functioning hypersonic missile, a missile that is maneuverable in its final phase, it is potentially a first strike weapon, because then you can nullify the enemy's second strike Star Wars shield and strike the enemy with impunity anytime you feel like. And the Chinese, not to be caught lying down, they have their own hypersonic program. In fact, they're developing hypersonic cruise missiles that can be fired very close to the ground and go underneath ground radar. Instead of being locked onto by the enemy's ground radar, the Chinese figure they can fly underneath the United States ground radar system and then strike U.S. ships with impunity. Well, with all this technology, what does it mean? First of all, the cost. The cost is going to be enormous. We don't know whether the laws of physics are compatible with some of the designs being cooked up by the Pentagon at the present time. And second of all, will it work? And third, of course, what are the Russians and the Chinese going to do about it? They're not going to take this lying down. They don't want to have their weapons nullified. They want to be able to evade, outmaneuver, fly underneath U.S. defenses which means more money being spent on a Star Wars shield. And so the question is, where does it end? Star Wars 2.0 could, in fact, unleash yet another round of very expensive hardware that may or may not work. Also, speaking about nuclear war, the Bulletin of the Atomic Scientist, a magazine that's been published since 1947, has the Doomsday Clock, a clock that is just a few minutes before midnight, midnight being doomsday, and last year it inched toward midnight. For a while, it looked as if the clock was going backwards because of the breakup of the Soviet Union and because of the fact that the North Koreans seemed to be open to negotiations. But, well, it's still 2 minutes to midnight. And why is that? First of all, the report issued by the Bulletin of the Atomic Scientist says that relations between the United States and Russia are reaching a new low, with Russia announcing a new generation of weapons, the hypersonic drone, and tensions between the United States and Russia, especially with the United States unveiling its new Star Wars program. And then we have North Korea, which goes back and forth, back and forth. Who knows exactly what the state is concerning negotiations? However, the good thing is that at least they're talking. Before, they didn't say much to each other, but now the North Koreans and the United States at least are talking to each other, which is always a good thing. But the Bulletin of the Atomic Scientist really focused on global warming. It said that in the future, up to 250,000 people per year could die because of disruptions in the atmosphere, and about 100 million more people could descend into poverty because of the disruption of the atmosphere. Because, of course, farming is going to be affected. Food stocks are going to be affected. People's homes could be flooded. Mass migrations could take place. And so the Bulletin of the Atomic Scientists have stated that 100 million people could descend into poverty because of global warming. Also, scientists at the South Pole, Antarctica, have announced that they've been able to successfully drill the deepest hole ever drilled into the Antarctic. Now, you may say to yourself, well, who cares? I mean, they're just penguins down there, and it's just a hole. So what's the big fuss? The big fuss is that if you drill an ice core into the ice of Greenland, the North Pole, or the South Pole, you can extract, like a tape recorder, the atmospheric conditions perhaps up to 1 million years ago, and thereby reconstruct the temperature and the chemical composition of the atmosphere going back millennia into the past. So in other words, it's possible to recreate weather conditions that we haven't seen for 1 million years. So here's how they do it. They get an ice core, which you get by digging a tube and drilling it right into the ice and extracting from that a tube of ice. When you extract the tube, what you find are bands of, well, dirt, charcoal, volcanic ash. By looking at the date of these bands, you can then date when the snow fell. Because we've dated these volcanoes very accurately, we know that if we have a band at this point, it means that this volcano erupted someplace on the Earth. And thereby looking at the bands, you can calibrate how far backwards in time you were analyzing. I had a chance to visualize this personally when I flew to Reykjavik once for a peace conference as the capital of Iceland. And I was given a tour. I went into the university where there was this gigantic freezer. When you walk into the freezer, there are racks and racks of tubes, long tubes like perhaps 50 feet long. And the scientists there gave me a tour. They extracted one of these tubes, opened it up, and showed me exactly what's inside the weather. They showed me that, yes, you have these long tubes of ice. These tubes are about 30, 40 feet long. The diameter of the tube is only about an inch and a half. But when you look at the tubes of ice very carefully, you can see stripes. These stripes correspond to volcanic eruptions. And by analyzing these volcanic eruptions, you can tell to the year when this ice fell, when the snow fell onto the Antarctic. And then by looking at bubbles, by looking at tiny little bubbles in the ice, you can extract out air when the snow fell. So you can get the chemical composition of the air. And then by looking at the isotopic structure of the air, you can actually construct the temperature as well. So not just the chemical composition, but the date at which the snow fell can also be calculated by analyzing very carefully the chemical and isotopic content of these little bubbles. So how far can you go back in time? Reliably, 600,000 years you can go back in time. However, it's only a matter of time before we can go back 1 million, perhaps even maybe 2 million years into the past to give a detailed analysis of the atmosphere of the Earth. And what we find is rather interesting. What we find is that carbon dioxide levels and temperature go up and down simultaneously like two roller coasters. So think of a chart looking at temperatures going back 1 million years, looking at the temperature and the carbon dioxide content of the air. And what do you find? Two arrows going up and down like two roller coasters in unison. And that's how scientists can reasonably say that, yes, we do know what the weather was like in the future. We can then calibrate this information with our computer programs and then begin to understand what the temperature and the weather will look like into the future. And also news from the physics front. Last week, we announced the fact that the Europeans are thinking of creating a new, expanded, better version of the Large Hadron Collider, which found the Higgs boson, winning a Nobel Prize for 3 physicists. And the question is, well, what about the competition? Well, it turns out that the FCC, the Future Circular Collider being proposed at CERN, Geneva, Switzerland, will be 7 times more powerful than the Large Hadron Collider, the most powerful atom smasher on the Earth today. But, not to be outdone, the Chinese and the Japanese have now stated that they, too, are putting forth their proposal for the successor to the Large Hadron Collider. The Chinese have announced that they want to build the Circular Electron-Positron Collider, which will hurl electrons and anti-electrons colliding them at 240 billion electron volts. That's a lot of power for an electron beam. And the Japanese, not to be outdone, have said that in March they will decide whether or not they want to go ahead with the International Linear Collider. It is not a circular machine at all. It is a linear collider, and it'll slam 2 beams together, one beam of electrons and another beam of positrons, and it's going to open up a new era in subatomic physics. Now, the Large Hadron Collider discovered the Higgs boson. What's next beyond the Higgs boson could be dark matter. That is, matter that makes up perhaps 90% of the matter in the universe, but it is totally unknown. There's a whole shelf full of Nobel Prizes waiting for the people that could figure out what is dark matter. Dark matter holds the Milky Way galaxy together. If it wasn't for dark matter, the galaxy would have hurled itself and come apart billions of years ago. It has gravity. So the gravity of dark matter holds the galaxy together so it doesn't fly apart because it is spinning too fast. Believe it or not, the Milky Way galaxy is spinning about 10 times too fast for its own good. By rights, it should fly apart, just like a pinwheel, but it doesn't. And that's where dark matter comes in. But dark matter is invisible. It's the most elusive form of matter in the universe. If I have some dark matter in my hand, first of all, it wouldn't stay in my hand. It would sift right through my fingers and go right through the pavement and go all the way down to the core of the Earth as if the Earth didn't exist and go all the way to China. it would then turn around in China and then go back to the center of the Earth and then oscillate back and forth between New York and China. That's how elusive dark matter is, and we are clueless in understanding the nature of dark matter. So if one day you ever figure out what dark matter is, well, tell me first. And then we can split the Nobel Prize together. Because quite frankly, we don't know. We don't know what dark matter is. And that's what the ILC in Japan may discover, or the CEPC in China, or the FCC in Geneva, Switzerland. And then you may ask a simple question. If the United States used to be the leader in all this technology, then where's the United States machine? Well, believe it or not, we had a machine 20 years ago. 20 years ago, we had the Super Collider, much bigger than the Large Hadron Collider of today. It was to be built outside Dallas, Texas. So the United States Congress gave us $1 billion to dig a gigantic hole, much bigger than the hole that made the atom smasher at CERN, and they canceled it. Well, Congress canceled the Super Collider and then gave us a second $1 billion to fill up the hole. So we got a $2 billion bill of goods to dig a hole and fill it up for nothing. Absolutely nothing. And that's the wisdom of the United States Congress. And so you have to realize that the United States Congress does not understand that the origin of wealth, prosperity, and power comes from science. Science, not taxes, is the reason why America is one of the greatest scientific powers on the planet Earth. But hot on the heels, we have other countries who want to dethrone the United States. And once again, the United States is not in the running for a new atom smasher that could open up new gateways to understand the nature of the universe. And one of the big mysteries about the universe that may be unraveled by these new accelerators is, are there other dimensions? Not just dark matter, but are there dimensions beyond the familiar 3 dimensions of space and time that we learned about when we were children? I mean, think about that. That's the prediction of string theory, and it's a testable prediction. And so with these new machines, we may be able to detect whether or not there could be parallel universes hidden in other dimensions of space-time. Not just science fiction, but real hardcore physics.